Going into section 4 of chapter 12, where we're dealing with applications in which we're going to solve what in essence will be quadratic equations. Now we're going to do one that involves the Pythagorean theorem, one that involves projectiles, where we're going to shoot rockets up into the air and have them come down. Quadratic equations in which we are involving geometry. And then one that deals with cost per person. Now I've looked these over already. Didn't want to be thinking about them too much. And when you do word problems, there is a strategy, and they're going to go over it here in some detail, so we'll take a look at it. Read the problem carefully. That makes sense, and often several times. Try to understand what they're really asking. Devise the plan. Now, what you want to do is define a variable to the thing you know nothing about. And then, using that variable maybe to define other things. And label these to a degree. Now, another good deal is to draw a diagram or set up a chart. We've done a little bit of this before. Then you write an equation that relates the information provided. Carry out your plan. Study the diagram. Does what you end up with make sense once you solve the equation? And then look back over it. Does the answer fit the question that they're asking? Your solution. And then check it. Okay, we're not going to spend a lot of time on this because this is what we'll use to illustrate all of this. So there's the Pythagorean theorem. Now if I were to get an example like this, I'd make a picture of a right triangle. I'd identify my sides and keep in mind that c squared equals a squared plus b squared. Now here's the problem. The length of a rectangular field, there's a field, you've made a rectangle, is 6 meters longer than the width. So you don't know what the width is. So you're identifying the width here. And you are identifying your length. Your length is 6 meters more than the width. Now they're telling you that a diagonal, which is this line here, stretches from one corner of the field to the opposite corner. So this is your hypotenuse. This is your C. So A, B, C. A squared plus B squared equals C squared. And again, you may have to ponder and study and read again the example they're going to give you. So the solution, as we say, we're going to apply the width. There's our length. And there's our formula. So they work it out, but I'll work it out with you here as well. And you could follow along. Remember, you're taking hopefully good notes. Now, this is a binomial that we're going to square. So square the first term. Multiply these two together, get 6w, double that. Square this. This is there already. And this is going to be 900. Group-like terms, we get 2w squared plus 12w. Now, we're going to subtract 900 from both sides so that this becomes standard form. And this then gives me a negative 864 here. And leave myself that much room. Alright, so we're just bringing this 900 to the other side and subtracting it from this leaves us with this negative number. Now notice they're all even, so we can divide everything by 2 to make our numbers smaller here. And this gives me w squared plus 6w minus 432 equals 0. Now, interestingly, all of these problems we're going to be looking at can be factored. And you can also use, of course, the quadratic formula, whichever you want to use. So W. Now, factors of 432 that have a difference of 6. Well, that's going to be 18 times 24. And you might say, how did I figure that out? Well, you could have gone to 432 and tease apart everything. And I have a calculator that actually helps me to figure this out too. But you're not allowed to use those. But at home, of course, you can play around with it. Now, which one's going to be negative? Which one's going to be positive? Well, we need a positive 6. So our outers, which will give us a positive 24w, our inners then a negative 18w, and that checks out, gives you a positive 6. So here w is going to give you 18, and here w will give you a negative 24. Now, we can't have lengths of something be a negative 24. So we reject this answer. So in our original right triangle here, our width is going to be 18, and then 18 plus 6 is 24, and the length of the diagonal path we said was 30, and these are our answers. And again, I did that quickly because I looked these over already. Just showing you the strategy. And going through what they have. Rejecting the negative. And there are your values for the short side, the long side. And we know the diagonal was 30. Okay, now for something like this, a bullet is fired straight up from the ground with a muzzle velocity of this many feet per second. When will the bullet hit the ground? So we're at the ground level. We're shooting the bullet, goes up, finally it runs out of speed and then drops back down to the ground. So ground level is 0 here, and we want a formula for this. Now the book gives us a formula, so we'll use that. We want to know our initial velocity. We want to know our final height in feet, and it's ground zero, so 0. And this is the formula we use. Now, I'm assuming they're giving us this formula somewhere. Here they're giving it to us here. But I would assume that in your questions you're going to get, they're going to say, this is the formula we use, initial velocity. So what do we do here? Well, we have to do some substitution. In fact, let's just do the substitution, because we know our initial velocity was this. So what do we do here then? Because we want to solve for t. Our ground level is 0. We started off at 0 for our initial height. So the first thing we should do is just get rid of any common factor. So we can divide this by a negative 16, this by a negative 16, negative 16, negative 16. So this then gives us t, and t squared minus 20t. So this one's easy to factor. So we take out a t, and we get t minus 20. Well, we had said we're going to equate each of these factors now to 0. So we got t equals 0, or t equals 20. Now, what does this 20 mean, or what does this 0 mean? Well, it's not going to be instantaneous, that it's going to rise up and fall, so we don't accept this as a possible answer at all. And this is our 20, that to reach from when it's shot to when it reaches the ground, it's going to take 20 seconds. And that's what happens in these places where people celebrate and they shoot bullets in the air. You know, in a few seconds, less than a minute, they're going to come back down and fall somewhere. And sometimes people get injured from that. Okay, let's take a look. So they're dividing through everything by a negative 16. They're not showing you that. Oh yeah, over here they're saying it. All right. Factor that. And again, this one's easy to factor. And there's the answer. Now, there's a second part to this, because they want to know, when will the bullet be 1,200 feet above the ground? So again, in trying to understand what's going on here, that bullet's going to be shot up into the air, reach the ground, and somewhere it's going to be 1,200 feet. Now it's going to be 1,200 feet going up, and then 1,200 feet going down. So we're probably going to get two answers here. And we want to know this one and this one. That's what they're asking. So we're using the same formula. But over here now, instead of reaching the ground and 0, we're saying it's 1,200 feet. The initial height was 0, so we can dismiss that. And what are we going to do? We're going to transpose this to the other side. That's what they're doing. And what do you think their next step would be? See if you can make this number smaller by dividing everything by a negative 16, and then you get this. Now, they want us to factor this, and let's see if we can do some brainstorming here. Now, here again, you could use the quadratic formula. If you're stuck, that's what you would have to use. Or you could tease this apart and see what factors give you a difference of 20. Now, if we look at this, five times 15, and notice our n sign is positive, so both these middle signs here have to be, in order to get a negative 20, have to be negative. So here we're going to get t equals 15, and here t equals 5. And what does that mean again? Well, at 5 seconds, it's going to be 1,200 feet, and at 15 seconds on the way down, it's going to be, this is time here, equals t here. It'll be 1,200 feet here. Okay. And, you know, they say the teacher makes things look easy, and having it all like this for us, it is sort of easy, but you want to follow and use this as a guide if you have one like it. This is your guide. It'll be in your notes. And there is our answer statement here, and it makes sense. Okay, this one, as I looked it over, was somewhat challenging. And we need to understand, and here a picture is almost absolutely necessary. So first you would make a rectangle. Didn't do that very well. And it's 6 inches longer than it was wide. So this is going to be our width, and this is going to be our length. Now, they cut out 3-inch squares from the corners here. And this is 3, 3, 3, 3, 3, 3, 3, 3. That when they cut these out, they're going to fold this up and make like a tray with these sides. Okay? Now, the volume inside this, once it's folded up into a tray, is this. So what were the dimensions of the original side? What was this length and this length here? Or this length and this width? So we know our volume formula. Volume equals length times width times height. Well, our volume we know is 336. Now, our length here is once you've cut this out. So we're looking for this length here. Well, we know there's 3 inches on this side. So once we fold it, we're taking away 3 inches here and 3 inches here. So this is going to be x plus 6 minus 6. So this length here is just going to be x. Now, what will our width be? Well, originally it was x, but we're taking away, again, 3 inches there and 3 inches there. So this is going to be x minus 6. And our height, we know once this is folded up, again, what we're looking at is something like this now. This is going to be 3 inches. So that's our height. So the first thing I would do, they didn't do this, but I would do it, is I would divide both sides by 3, which they're going to do eventually, but let's do it now. So these 3's just cancel out, and this becomes 102 equals, this is going to be x squared minus 6x as I distribute that. And then they're going to go x squared minus 6x minus 112 equals 0. And they're going to factor this. Get all of these factors. And I did some of this before. You'd have to fiddle with it. It's 14 times 20 is no, I didn't do that right. Let me go back here. Again, I'm looking at my notes here, but I realized when I did that mentally, that wasn't going to be 112. This is it here. All right, so what will our signs be? Well, this is going to be a negative 14 and a positive 12 to give you a difference of negative 6. So that when we multiply negative 14 times 8, we get the negative 112. So this is going to be x equals 14, and this will be x equals a negative 8. So we see that negative 8's not going to work, so we cross that off. But our 14 would. So what is this side here? And let me just erase a few things here. We are saying our x here equals 14. Then what is the length? That's our width. What's our length? Well, it's going to be 14 plus 6 is 20. And that's where I mistook it when I looked at my notes to see this here. Okay, so this one was rather challenging, and I see we are over 20 minutes, but we'll let it run because we want to keep this a little bit simple or whatever. So there's the height of the box. The length of the box, remember we had to subtract 6 inches from it, so it ended up being x. The width of the box, we had to subtract 6 inches from that, so that's where we got our x minus 6. And then there's length times width times height equals volume, and there's a really nice picture. And again, what I did is I divided this 3 out from both sides. They didn't yet. They're going to do it now. Okay. They get this. They factor it. They reject the -8. And our sides are, the width originally was 14. The length was 20. Okay. Wow. Now, as we go on to the last problem, and we're going to just stay with this, we have members of a bowling club were going to rent a bus to drive them to a tournament at a total cost of this, which was to be divided equally among the members. So, this is our total cost, 2420, divided by the number of members, which we don't know, which is going to be X. Now, at the last minute, 2 of the members decided to drive their own cars. So the cost remaining for those members, because 2 of them were not going to contribute, increases to $11 each. Remember, this would be the total cost divided by the members. So this would equal a certain average here. But we're saying once 2 of the members pulled out, this average cost increased by $11. Now, what's this new average cost, which is going to be higher because there are fewer members there? Well, the price of the bus stays the same. But now, instead of dividing by the larger number of members, there are going to be 2 members less. So, if this were like $140, once we subtract what it would have been, which would have been like $129, the average cost is increased by 11. So this is the formula. Now, our challenge is to solve it. Now, whether or not you're able to do this, this is the challenge of it, but this is what the book is showing us that they're using as a method here. You have to put it into standard form of the quadratic equation. So let's see what we get here. And there's our equation. So again, this is a larger amount average. This is the regular amount if all of them took the bus, and the difference is this. So this wasn't too hard to figure out, but now figuring out the actual equation, you had to get rid of fractions here, so they're multiplying every term by the lowest common denominator, which happens to be this. And you can copy this in your notes, because they're showing it in some detail. Then they're multiplying through some more to get rid of this parenthesis, and then now they're putting it into standard form. Now, fortunately, this all divides by 11, which they're doing here, and now we just have to factor this. So, I noticed when I checked this out earlier, they didn't factor it properly here. They have the right answers, so I have to cross that off here. So it's X and X, 20 and 22. Now they want a negative in the middle, So this will be a negative 22, and this is going to be a positive. So this converts to a positive 22. This is a negative 20, and when we're counting individuals, you don't have a negative number. So our initial grouping was 22. But that's not what they're asking. They're asking in this question, how many rode the bus? So that answer would be this minus 2, and it would be 20. Okay, there's a lot of algebra here, but we're working on particularly in putting it into an equation, and I'm not going in great detail of how to solve this. That's a challenge. So let's go on and take a look. And there's our check. So now the 20 members are paying this, where if there were 22, they would have paid this. And you see now the original price of 110, because there were fewer members, went up to 121 per person on the bus, which increased their price by $11. Okay, so that worked out. There is your initial equation here. If all the members rode, it would have been 110, but 2 fewer rode at 121. So 20 members rode the bus. All right, well, this winds up this section.